Uh, Hello, everyone. My name is Jana Machutová, and I'm a software engineer in Gen Digital, and I'm here to tell you some stories from a parallel universe. And as a universe is parallel, all the stories should be told in parallel. So what came to my mind when we talk about parallel and concurrency are all those dangerous words. And yeah, it's kind of shame because the C++ itself is quite complicated language. It's quite complicated to learn, and when you want to work in a multi-threaded environment, when you want to make a multi-threaded application, you need to learn something extra on top of it. You need to know what is the memory model. You need to know all those words. You need to get a lot of practice to not get lost and to not make too many mistakes because they are really hard to find and debug. But there are only a handful of programmers which are able to do that. But we are living in multi-threaded world, so it should be more available for more people. So it will be really nice if there will be some tool to make it easier, like for more programmers. And there actually is. We actually have some small medicine for that pain, and I will talk about that. It's a standard library parallel algorithm, which will make it easy for you to parallelize your computations. You may get rid of those words you see, mostly, and you may easily use that. So I will be your guide through that journey. So what's that standard library parallel algorithms? I believe that all of you know the algorithm of standard library. I hope you are using some of them, that you are not writing your or sorting algorithm functions, that you are using these. They are pretty straightforward, easy. There are a lot of them. They are useful. And it will be really nice if you can use exactly the same. Just tell, run in parallel. Do it in parallel. I want that. And it's actually possible. All you need to do is add one extra parameters. Most of those algorithms has overload with one special extra parameters at the beginning, which is the execution policy, which is there just to tell how do you want to run that algorithm. If you want to run it sequentially in parallel, there are more options. For now, we will stay just sequential and parallel, and we will go deeper later on. So it will be also nice because you will use the same algorithm from sequential and parallel, and you can switch easily. You have just one simple word you need to change to switch between sequential and parallel computation. So you can easily debug, easily switch, easily measure your performance. And you will get well-optimized, well-known solution, widely used, so you don't need to develop it by your own. So don't reinvent parallel wheels and use standard library algorithms. That's the message of this talk. And it's good to see it in examples. So through all this talk, I have this is sea level. If you haven't recognized it, it's a sea level. And we will have two worlds. One will be in the sky and one will be under the water. In the sky, there will be everything in the same way you already know it. It will be sequential or using threads and so on. Under the water, everything will be using just the parallel algorithms. So you will be able to compare those two easily. So first, we will create our world. Our world is full of animals. In the sky, there will be butterflies and some eagles and swans and whatever. Underwater, there will be tons of fishes. And we have the vector of the species. And what we do, those animals doesn't depend on each other. Like they live their own lives, so they can have each their own thread. So I create some vector of threads, and every single type of animal will get their own thread, and they will fly high. It's the old-fashioned code. It's just like that, no trick. This is how it will look with parallel algorithms. No thread. You won't touch any thread at all. It's way simpler, and all the differences, it's execution per unsec. it's the execution policy I mentioned. So the whole difference is you don't need to deal with the lifetime of the threads. You don't need to manage them. Otherwise, the logic is the same. But does the code do exactly the same? Because what if I do million threads, million kinds of animals? Will be the result the same on both of them? Actually, what will happen in the first example? You will try to create a million threads, like really? You won't succeed. You need to do some more logic about that. You need to do some at least simple management of threads. But in parallel, it's done for you. There's underlying thread management. You get for free. You don't need to care about it. It's different for different implementation, but it's handled for you. You don't need to care. So what you need to do to actually use that? That functionality is available from C++ 17, where the execution policy appeared together with that overloaded algorithms. And there are a few updates over the C++ 20, and there will be some more probably, but it's possible to use it from C++ 17. What you get, that clever thread management, that already in the stage you may forget for all the threads. You don't need them. It's so much easier, isn't it? So, yeah. And together with that execution policy, then there appears several new algorithms in the library. And also some old algorithm doesn't have that parallel overload, that you can't put their execution policy. And they are tightly connected together. It's not an accident that it appears with the execution policy. And I will go to those special algorithms. I will explain what are the catches in there. But all the others can be used just as I show you in the first examples. What is pity so far? It's not available for ranges, so I will always show you the begin, and it will be because of that. It's not possible so far, but there is a paper for that. I think it will be there in future. So what are those new? How many of them are there? So all of the new algorithms are just alternative to existing one. So those accumulate in the product, and partial sum are those which don't accept execution policy. You can't run it in parallel. But they have their counterparts, reduce, transform, reduce, and exclusive, respective exclusive scan. And it may not be really intuitive why there are those differences. If you read the documentation, you will get an impression like they are doing exactly the same. What should I choose and why? So I will show you the differences one by one. So first, couple is accumulate and reduce. So what we will do, we have our animals, and there are different count of different animals, like there are 68 of butterflies, 15 eagles, 4 swans, for example. And we want to know how many animals in total do we have. That's exactly what accumulate does and what reduce does as well. So it looks like that. Again, there's only execution policy in the reduce. And otherwise, it seems to be exactly the same. You get the container, and you have initial value, and you have the same output. So why there are two of them? Well, the reason is that because there's a default parameter, which is by default both are plus. So you have, in accumulate version, you have 68 plus 15, that all plus 4, that all plus 45. But you may define something else in there. You may do your custom binary operation in there. And that's an alert. That's examples are really stupid way on how to solve those issues, but I have a point to show. So yeah, you can say you will solve it different, but our animals are having a good time, so over the year they will double their amounts. So we want to know how many animals will be there next year. There's a growth factor, they will double. So we will take the binary operation, where the first is what we had so far. It's the initial value at the beginning, the 0. The second is the item we want to add to there. So we want to 0 at 2 times 68, and so on. So we do the same for reduce and accumulate. And do you think we will get the same result? No, we won't. And I will guide you through the flow of those algorithms so you can find out why and what is the difference. So first, accumulate. It's really straightforward. Like you have the vector, initial value, and you have the first is the sum we already have, the initial value, and we add the double the 68. Nice and easy. Second one, we will take the output and add another item. And that till the end, and we have the correct answer. It's the correct one, it's okay. So, but what is, why this can't be parallelized? Because every single step depends on the output of the previous one. So that's not possible to parallelize this way. So the reduce does it different way, and the different way probably break our computation. So we will have a look. So if you want to parallelize something, what is the first thing we will do? We will have to split it. And we have binary operation, so we will split it up to the pairs. And we will apply that operation to all the pairs in parallel. Nice and easy. What will be the next? Okay, another pairs. We have 3 nice reduction. Pretty easy, but the result is wrong. Why is that result wrong? This is, I've written down what the computation actually looks like. It's like this, but what the accumulate does is this one. The only difference is in the brackets. The brackets are in different places. It means that our binary operation is not associative. That's the point. We can't parallelize, we can't reduce with non-associative operations. So that's the reason to keep those both algorithms. But we can fix it in this case, and in most cases, I believe, because all of those algorithms have their transform version. So we can put that multiplication in the transform, which will be performed before the reduction. And then we will only sum up with the plus operation. So from this, we will get to this. That transform is really nice because it's performed once the item is really touched. So it's better to put it inside that algorithm than do it somewhere else. So we actually fixed that accumulate bug, and if you can do associative operation from you always should use reduce. You always should use the under the water algorithms if you can. Those old ones there are just for the computation which can't be transformed to associative. So what is the next one, next problem? We have inner product and transform reduce. So again, we have our counts of the animals, and they have some weights. We want to know what mass is floating in the water and what mass is flying. So what we need to do with multiply corresponding items of counts and weights, and then sum it up. So that's exactly what inner product does, and transform reduce. Again, the output with the very simple example is the same. Again, they are optional operation you may use. But now I won't go the same way. I will try to put some real weights in there. Like the heaviest should be the weight of whale in grams. The smallest is something I made up. But that's quite a large range of weights, and we will try to count it. And what we get is different, even though we didn't get at there any custom operation at all. Like, do you know someone not you, guy. Why is that? Well, I will first want, yeah, you know?
Because the order of execution for floating points matters.
Yes, exactly. So first of all, I will check the correct output just by adding some precision with doubles, so I have the same result, so it's probably the correct one. But yes, the point in here is that floating point addition is not associative. And I'm mentioning it here. You can't fix it anyhow, but it's good to know, because if you will get your sequential algorithm and convert it to parallel and you see different results, it may really confuse you, even though it's just how float behaves, but it may really confuse you. So it's good to keep it in mind, to not get scared. Oh, I have different result, I have some bug in there. It may not be that. Just remember of non-associative float. Okay, so another one, the partial sum. It has actually two counterparts, inclusive and exclusive scan. And what partial sum do? Actually, if you still remember what accumulate does, partial sum is the same, but it will leave you with the intermediate result as well. You don't get one value, the sum of all, but you get all the sums for all the items. So we will find out what will be the amount of food for each that animal. Like we will take, they are sorted, the animals are sorted for the smallest one to the biggest one. And each animal can can go and eat all the smallest animal, smaller, and themselves, their own kind. It's inclusive scan, yeah. A partial sum equals to inclusive scan. It's good to know, because sometimes I was like, it's exclusive, inclusive? Partial sum is inclusive sum. It's in the basic form, it's the same. But again, we wanted to know it for the next year, so there's obvious trap, I guess. It's again the same mode. It's the associativity. You can see the results are different. And here I want to mention that maybe if you put exactly the same code, you may get even the right results there, or different results, because the optimizations are different, and I put it to my naive implementation. I will share code with you so you can try it. With very naive implementation, you will get those outputs. But it depends on how optimized it actually is inside. So what happened in that partial sum? Actually, even in partial sum, we had a bug now, because we want to increase amount of every single item. But partial sum, unlike accumulate, doesn't have initial value. So the first item is just copied. The first pair is the first and second item of the vector itself. So the first one wasn't multiplied. So it's just good to mention. Otherwise, it's exactly the same like the accumulate, with that small differences. So we get correct results. All the vectors result. The first one is not what we wanted, but yeah, it's our code. What will go on in inclusive scan? And I wrote naive inclusive scan. It's not how it is really implemented, but it's useful to get the idea how you can parallelize it. So we have our vector, and it will really help us to see the indices in this case. So what would we do? The first one, we can just copy to the output. Great. Second one, okay, input and output is the same, so we will change the input for output. And yeah, we can't use output because we will have a dependency in here, so take the inputs. Do it for all of those. But it's not what we wanted. So what did we get, actually? There are those indices for that. So we had to do inclusive scan of small vectors, of those 0, 0 to 1, 1 to 2. And we actually can see that the first two items are solved already. We have the result there, the 0 and 0 to 1. It's exactly what we wanted, so we can just copy it. And what about the third one? There is 54, and this 1 to 2, only missing is 0. So we will add it. The next one, 2 to 3, missing 0 and 1. It seems like a pattern. We will use it for all the rest, and we will see what is the result. Actually, we have first half of the vector is already solved this way. That's nice. So what with the rest? There's the same pattern. We will just take the input, and we have it all. And this way, we have the correct result. Unfortunately, this is not correct because it's not associative. But if you don't think about about this multiplication, this works like that. Actually, the reason why it's not implemented like that, you have the synchronization point in there, which are quite huge. So it's possible to avoid them. And Bryce had a nice talk about how to really implement it, how is it really implemented. So you can check it out. But for basic understanding, this is the logic behind. So yeah, non-associative, but really effective. So what can we do to fix it? Transform. Transform will fix everything. So do we get the correct answer now? Yeah, we have it correct, but not the same like partial sum. Because the transform will transform all the item, unlike the partial sum, which omits the first one. So I think this is even a better result, but if we are converting our old code, we want to have the same results as before. So you need to basically subtract 68 if you want to have it right, or do some little bit workaround. It's good to know that it doesn't correspond absolutely. So what's there next? Does it work? Yeah. So all the rest is exclusive scan, inclusive, exclusive. Both are alternative to partial sum, so it's good to know the differences to use them correctly. And the real difference, exclusive scan has the initial value, and in our term of animals, in exclusive scan, cannibalism is not allowed. It's all the difference. It will get the sum of all smaller animals, but not ourselves. Inclusive, cannibalism, exclusive, no cannibalism. So what you will get are those results. Basically, I will show in a flow. In exclusive scan, first you get the initial value, which would put there. In inclusive, you get the first item. So I think it's pretty understandable. This is a difference if you take the previous or the current. Yes. So I will try if I can simulate that partial sum with exclusive scan. It wasn't possible with inclusive, so probably with exclusive it may work. So I will start my vector for the second item, not the first, and use the first as an initial value. It won't be transformed there, no? It may be like that, but you don't get all of the item. You have the smaller vector. You have to somehow compute the last one. So yeah, it's also not exactly the same, but you can do simple workaround if you know about it. So these are all. There are no more complications. All other algorithms are just working like you know that. Just put in execution policy and then works. Only those are complications. And if you understand what are the differences, you are free to go. You can use it. Don't forget they have transform version, which may help you to adapt your computations. And yes, always prefer those under the water, because you can parallelize them, unlike those under the water. And basically, you give some promise. With those under the water, you give some promise that you use associative operation. And each promise gives some space for some optimization. It's good, even for sequential, maybe. So use use only the underwater. The old one above there's some only for computation which are not possible to convert. Yes, and be aware of floating point non-associativity. You can do anything with that, but don't fall to the trap. So I will push all those small examples together. we will count all those food in weights and increase in just 3 simple lines, 3 transforms. At the beginning, we have the counts of animals at years 2024. Next, we will do our first transform using the simple multiplication to see what are the numbers in year 2025. Next, we will take a vector of weights and make another transfer to see the mass floating around in the next year. And the last step will be the exclusive scan to see, because I don't like cannibalism, to see the food available next year. But yeah, there's something I don't like about it. Those are synchronization points. They are not needed to be there. You do nice parallel work and then wait for it all to be done and then start another and then wait again. You may use one small trick in there, and the trick includes views. Because as you know, views, if you create a view, it doesn't give you back the vector of items. It gives you just a prescription how to get those values. So if you transform it, zip transform, which basically 2 vectors with binary operation over their respective items, you get a view which you can put into that parallel algorithm. And once it will touch it, that item for the first time, it will be computed. So you won't have any more synchronization point in there. So it's a nice trick. Of course, you can put that one transform inside exclusive scan directly, but zip transform, no. You have to use the view for that. And so, as I said, all the rest of the standard library algorithms can be used in parallel version without no pain. And some of them may require additional allocation, like in parallel, you may need to store some temporary value somewhere, so it may have some small memory allocation on top of it. So, and at some implementation, maybe not all of them are implemented. It depends on the implementation, but don't worry, the worst you can get is what you already have. So all you need to do is add execution policy. And I think it's already time to talk about execution policy, because I mentioned it so many times and haven't told what is it. So it's a first parameter of each parallel algorithms, and it defines how much it is possible to parallelize the code inside the algorithm body. And for the best result, you should go with the strongest one, because if you are not able to go with the strongest one, that indicates that you need some synchronization, some control over the flow, and maybe it won't perform better. So the first rule of all those optimizations is always measure before and after every time. So which are they? There are 4 of them. As I said, sequential and parallel, these are straightforward, but also unsequenced and parallel unsequenced. So the 4 of them, and I will go into showing the differences. So first one, I think everyone is familiar with, just sequential execution once after another, all in single thread, no parallelization. If you won't use any policy at all, it will run sequential. You don't need to put that parameter in there. Another one is parallel. Code is executed in multiple thread, and you don't know what will be the order in which they will be evaluated. And you need to control the access to the shared memory, because if you want to increment the counter from multiple threads, you will have a data race. So if you have a parallel policy, you need to secure access to the shared memory, atomics, logs, whatever you want, but you need to think about it. Another type of policy is unsec. It's for vectorization, so it runs in a single thread, but more of the item together. So in this policy, there's no synchronization allowed. It's not even atomics. And it will look something like this. There is a bunch of items which run together, and then another bunch of items which are processed together. And what may happen if you will lock that access to counters to make it? So 4 of them will be executed together. In unpredictable order, they may be interleaved. And so what happens when they are interleaved? We are in single thread. We are locking counter, we are locking counter, we are locking counter. From a single thread, we can't do that. So that's basically the reason why you can't synchronize in unsec. And parallel unsec is the strongest one. You should always try to go for this one. It's parallel and unsec together. It's multi-threaded and unsequential. So about the rules, it's exactly the same, like with the unsec. Just don't think about any synchronization. Don't access any shared. So I think that from theory, it's basically all. So I have some question for you in examples. I have a very simple example in here. There are fish which has its position and some speed which is flowed. There are a lot of them, and we are moving that fish over the time. Is this possible to run in par unsec, or does it need some different? Who is for par unsec? Yes, it's very simple one. There's no catch. It's the simplest one. But if we add the shark, I have to say that shark may appear somewhere. It's not written in the code, but it's not constant. Shark may change. Shark is not there, and it may appear somewhere. So the fish is looking if there is a shark. If there is, she runs away. Otherwise, she's floating happily. So what policy is possible to do here? Is it par unsec? No. No. Is it par?
Is shark an atomic bool or a bool?
Sorry?
Is shark a variable, a bool or an atomic bool?
You have to, if you want to parallelize, you have to change it. Yes. So yeah, you can make this happen in par, but you have to make it atomic. Exactly. Yeah, atomic shark. If you have atomic shark, you can go for a par, never for par unsec. So another one. We have hideouts. Like if the shark comes, the fish may hide somewhere. The hideouts have their position and some slots, how many fishes can fit in there. So our fishes are running away from the shark. They select the nearest hideout, the closest one, and they have just some speed they can swim for there. They can be faster. So once they will go there, they have to look if the slot is free, so it can stay hidden, or otherwise it may try some mimicry to not be spotted. So what can we do to make it? Can we make it par unsec? No, there's need to modify the slot. If someone if the fish is hiding, she needs to decrement the number of slots available. So we are modifying something outside. So no, but we may do it par by making it atomic or lock it or just secure the access. So I believe you already get the point. So there are, I'm sorry, I have to. So I wanted to show you also the trap, which is the unsec policy. Here we have a group of the fish, and only one of them may be a leader. Everyone wants to be a leader. So what they do, they are trying to, because we already know we need to lock. So they are trying to lock the attacks, see if they can take the leadership, and if not, they will unlock it and swim around and try it again after some while. Once they acquire the lock, They will set themselves as a leader and unlock, and they will live their happy leader's life until they die, and they will free the leadership. Once they die, someone else may come out from that loop. So even though we locked it, what will happen in par and sec? Multiple locking for the single thread. Yeah, not really good. But maybe we can solve it with atomics. I said it's not possible to do atomics, so what's the trap in here? Actually, one item of that bunch, again, he's happily living his leader life, and then he free up his leadership. And this is one item of that unsec fishes. And what will do the another? I said that they may interleave. So this one will go in between somewhere, and it will deadlock forever, because the first one will acquire the lock, and second one is asking for it forever. But the freeing of leadership is sequenced after that, so it can't never happen, and it's all in a single thread, so it's necessary to mention this one. So what we have found so far. Oh, I have also one more question. If you can find out, I was quite a long time I was looking for an example where does par unsec and unsec differ. If there's an example which will go different way with par unsec and unsec policy, does it something came to your mind where it may differ? Because it has exactly the same rules. You can't use any locking at all. You can use any atomics. So, is there something that you may think of which is different? I couldn't find it. I have to actually ask some other people, and one told me that nice idea, thread local. If you have thread local and you initialize it with some value, you have that value only at the one thread. It will work nicely in unsec, but not in par unsec, but it's the only one I was able to find out. Otherwise, you may treat it as the same. So, what's the takeout? Use standard library algorithms. Your life will be way easier. It helps you a lot, and now it helps you with parallelization as well. Use always the strongest possible policy, because the weaker means that you need some synchronization. Some synchronization means that your performance won't be that great. And try to avoid the data dependencies. The synchronization impact is huge. And always measure your performance, because that you put it into parallel algorithm doesn't mean necessarily that it will be better. And yeah, beware of non-associative operations. For some other talks which you may appreciate, like I said before, Bryce was exploring more about the inclusive scan in Think Parallel talk, and from there are two in this conference. You may see both of them already was on a program before, but yeah, some recording maybe. And if you want to dig deeper on how it is actually implemented, those are two implementations available of parallel library. And all the examples I showed and as presented are in here together with the presentation. So if you want to play with that a bit, you can try it out. And I was talking too fast, I'm sorry. That's why I got so nervous. Thank you. Thank you.
All right. Questions?
So thanks, very insightful talk. Was really interesting. I would have a question on the inner product. You said that you might get floating point issues.
Mm-hmm.
any idea how a strategy for a unit test could look like? For example, if I implement something on my local machine,
Oh,
and
yeah.
I submit it to the build server, which all of a sudden has 64 cores instead of 8. Anything I can do for doing a unit test apart from implementing an epsilon or something? Or is
Yeah.
this the way to go?
It's just the way to go.
Okay.
I don't have any idea how to replace. It's just the different results anytime.
Okay.
Sorry. I wanted to find it out here, but yeah.
Can you impact the number of threads that are being used?
Sorry?
Can you impact the number of threads that are being used? Tell the library to use 8 or something.
I'm not aware of that.
Or it
You,
will
you,
always-
you should rely on the underlying threat management.
By default,
Yes.
you will try to maximize.
It depends on implementation. It's really
Okay.
implementation detail, which depends on. Yeah.
Okay, thank you.
So there's actually two online questions that are very similar. So I read the shorter one. What is the minimum data size to make using parallel algorithms advantageous if the data size is small, because else it might be more expensive?
Actually, from what I've observed, but I didn't measure it, it's like with the small data set, like I would have an example, it doesn't paralyze at all. So you shouldn't be punished by that. But yeah, I don't know the borders. But the implementers knows about it, and it's not like paralyzed to the last item.
Thank you for the talk. One question: if I already have worker threads, can I use them, or like, let's say globally, like tie them to something and then just do the call without providing anything?
Oh no.
Thanks.
Sorry, I won't go deeper.
If we are multi-threading some algorithm and we want an external variable to read, we are not modifying it, would you recommend to copy that to avoid an excessive amount of access to this local resource from the multiple threads, or have you experimented maybe on that?
I haven't experimented on that, but if it's a small variable, it's probably worth copying. I think it will depend on the size of what you want to copy.
Okay, other questions?
Please don't take this the wrong way. I really don't mean to be a jerk, but I'm not a native English speaker either. But isn't the plural of fish in this context, wouldn't that be fish? If some native English speakers could correct me.
Sorry.
Like you said, fishes.
It's
and
more.
isn't
It's
fish-
more kind of fish.
So it's okay. Yeah, but it's seriously, it's an honest question now.
Yeah, it's because it's more kind of fishes.
Okay, so it's okay. Okay, thank you very much.
All right, then thank you very much.
Thank you.